So basically, the last class, we have completed all the topics of the module 1. Okay, so we have covered the data warehousing part, and that was very important because you have to know basically how the data is being organized, modeled, right? Different schemas and main motive of the data warehouse or the purpose of the data warehouse in the data decision making. That things we have discussed, and thereby we have completed the module 1. Now, in this module, we are going to discuss about the, just 1 minute. Now, here we are going to discuss about the topics which were in our first module. First, let's discuss about the term data mining. So, data mining in general terms means mining or digging deep into the data, which is in different forms to gain patterns or to gain knowledge on that pattern, right? So, in what we are trying to do, we are trying to dig out some important information from that data we have, from the big amount of data we have, right? And thereby we try to find out that pattern and knowledge on that pattern. Now, in the process of the data mining, large data sets are first sorted, then patterns are identified, and relationships are established to perform data analysis and solve problems. This is a very common term, you can say very popular term in data mining, that is KDD process. Now, data mining as a knowledge discovery process in the database, which is commonly known as KDD process. There are a few steps that involve in this knowledge discovery process. Let's discuss each step one by one. First one, we have data cleaning, right? And in this steps, the noise and inconsistent data is removed. You know, when we have collected the data or we have collected data from different sources, then that data set may be consisting of noises or irrelevant data or some inconsistent data, which is no way related to our decision making process. So what we have to do, we have to first clean them, right? We have to first remove the noises. So that process is known as data cleaning, or sometimes it is also known as data cleansing. Data integration. In this step, what we do, we have multiple data sources and we try to combine all of them. Means we collect data from different sources and thereby integrating them. Then data selection. See, we may be having a big amount of data, but not all the data are equally important for us. So we have to find out what data are relevant to our decision-making process, current analysis process, right? And thereby we select only the relevant data from the data set we have collected from multiple sources, right? So that's why this step is known as data selection. Then data transformation. Here we transform the data or consolidate the data into some forms, particular forms that are appropriate for mining by performing summary or aggregation operations. Okay, basically it means we try to convert the data into one single form which is appropriate for the model that we are working with, right? And then only come the stage known as data mining. And here we employ some intelligent methods in order to extract the data patterns. Okay. So data mining state, what we do, we will take the help of some algorithm, basically ML algorithms, which um, actually help us to extract some patterns from that data. And next stage, because the output in the data mining stage is what? Some data patterns. Now next stage will be pattern evaluation. Whatever the patterns we have got from the data mining, we will evaluate them in this stage. Then we have knowledge presentation. Here, the knowledge means what about the pattern we have got, that will be represented in a proper form that the outside users also understand, right, about the details or inner details of this data. So if we try to represent this process, data mining as a KDD process, with the help of a diagram, then this somewhat looks like this. This diagram is important. See, this is database, right? Similarly, flat files. So from different sources, we take or collect the data, then we clean it and integrate it. Then we select the relevant data. We transform into the form that is acceptable in our model, means the form that where means we are going to employ some algorithm. That form is okay for that. And these algorithms I'm talking about is falling under what? Some data mining algorithms, some intelligence functions, or you can say methods, or you can say algorithms we employ to find out, to dig out the patterns inside the data. Finally, we evaluate the pattern and thereby presenting this knowledge in a form that the outside users will understand. Right? You can take a screenshot of this. This diagram is very important. Now, there are two forms of data analysis that can be used for extracting the models describing important classes or to predict future data trends. These two forms are classifications and prediction. Let's come to the classification. So what is classification? With the help of few examples, I will try to explain this term classification. Okay. A bank loan officer, say, wants to analyze the data in order to know which customer, or you can say loan applicant, are risky, which are safe. Because if you are giving the loan, you have to know about that customer, whether he is in a position to safely return the loan, or if there is some kind of risks, means we cannot trust that customer. So we have to know, we have to analyze his details. So in that case, we have to classify the customer either a risky or safe one. Similarly, a marketing manager at a company needs to analyze a customer with a given profile who will buy a new computer, because we don't need to show all the laptops to everyone, right? We have to show it to those only where there is a probability that he or she may buy the laptop. So this way, what the manager will do, he will try to classify the customer that he has. This one is, there's a probability he is going to buy, and this one not. So these are some examples of classification. Then what is prediction? Again, with the help of example, we try to understand this term prediction. Suppose the manager needs to predict how much a given customer will spend during a sale at his company. Okay. Here, we are bothered to predict a numeric value. Numeric, right? Continuous value. And the data analysis task is an example of numeric prediction. we will employ or we will construct a model, a predictor that predicts a continuous values function or ordered value. Okay, so whatever the prediction here we are doing, their outcome will be some value, some numerical value, right? As for example, you can consider regression analysis as a statistical methodology that we mostly use for numeric prediction. So to this example, we understand these two terms. First, classification, and next, prediction. The thing is that how this classification works. Data classification, this process includes two main steps. First, you have to build a classifier that, if trained, that is known as model, then using the classifier for classification. So first we have to build the classifier. Then next step will be, of course, we will use this classifier for classification. So first step will be the building of the classifier or model. And this step is the learning step, or you can call it as a learning phase. Here, the classification algorithms build the classifier. What we'll do, we'll select one classification algorithm, we'll train an algorithm, and if it is trained properly, then we will come up with one model. Right. The classifier is built from the training set made up of database tuples and their associated class labels. Each tuple that constitutes the training set is referred to as a category or class. These tuples also be referred to as a samples or object or data points. Got my point? So every tuple will constitute some training set, and the training set data, and that particular one will call it as a particular class or category. Now, if we want to show it with the help of a diagram, you can see here, this is the training data. Obviously, we have one data set, we divide it into two, we split it into two. Now, you can consider this is the training data. Here we have this data of some, say, customers, the name, age information, income, loan decision. So these are some earlier records. Sandy, say this one that I consider, Sandy, who young, falling under young, is income is low, so loan decision will be risky. Bill, young, is income low, low decision risk. Then Rick, middle-aged, high income, safe. Loan. Ultimately, what we are trying to do, we are trying to find out those customers who are safe, right? So we have to divide. You have to find out those who customers are risky or who ones are safe. So this data we will take and we will consider for training our algorithm, and then that algorithm would come up with some rules. They are known as classification rules. So from this data, if you observe manually also, you will find that if age is young, then loan decision is risky. If income is high, then loan decision is safe. If age is middle age and income is low, then loan decision is risky. This type of rules we have found out, we have got after this algorithm been applied, right? Now, as we have constructed our model, we have developed, so we develop our model. Now that model or classifier we will use for classification. In this step, this classifier is used for classification, and here we will use test data. So test data is used to estimate the accuracy of the classification rules. The classification rules can be applied to the new data, right? And if the accuracy is good, then we will consider them as acceptable. So this time, this new data will be there, test data, and classification rules been tested on the test data, then we find out the accuracy. So we have seen there are two steps involved in the classification process. First is the learning step, or known as training phase, where we are constructing the classification model. Different algorithms are used to build the classifier by making the model learn using the training set available. And we have to train the model for prediction of accurate results. Then classification step. So after the learning step, obviously we come with the classification step. Here model is used to predict the class levels and testing the constructed model on the test data, and we estimate the accuracy of the classification rules. This is a general overview of how classification takes place or how classifier works. Now, you have seen that we are using training data, we are using testing data. What are that exactly? So that is nothing but a data set, the same data set, we are splitting it into two, training and testing. Let me give you an example. Suppose there is a person who is sitting under a fan and the fan starts falling on him. He should get aside in order not to get hurt, right? So this will be his training part to move away when the train is falling down, right? Now, while testing, what we'll do? While testing, if the person sees any heavy object coming towards him or falling on him, he has to move aside. And if he moves aside, then the system is tested positively. Okay, we have trained with a fan, right? A heavy object falling on him. Now, next time in the testing phase, if any heavy object is coming towards him, falling on him, then if he moves aside, then our system is tested positively. But if the person does not move aside, then what will happen? Our system is actually negatively tested, right? It fails. So same, this with this example, I just want to show you that how it works. So this is the same case with the data. It should be trained in order to get the accurate and best results. So I think this is sufficient for today. Please go through it properly, and any doubt, ask me. But basically this diagram I'm talking about, try to draw it properly. This is important. So thank you. If questions, then you can ask me.